Hello everybody. The keypad on my wireless keyless garage door opener, my remote keypad, recently stopped working, and I figured out what the problem is and how to fix it. So let me show you. My model happens to be a Chamberlain 376LM, but my repair procedures here probably apply to any keyless entry opener that has a 9-volt battery. So the first thing I did was remove the circuit board and keypad from the enclosure. I would recommend not doing this if I were you. If I were to do this again, I would start with the solution I'm going to show you in a moment here. But I would not take this apart. These two plastic pieces are bonded together. I don't know whether they're fusion welded or vibration welded or how they're attached, but I had to break that bond, particularly up in this area here. The side bond was a little bit easier to break open, but this top bond is a little difficult, and you can see here I've got this a little broken. So I'm going to have to super glue this back and probably use my high performance glue to put this back together again. But you can repair this keypad without taking this apart if in fact your problem is the same problem that I had. A couple comments here. I'm surprised in what good condition this circuit board's in. Think about this. This has been outside for probably the better part of 7 or 8 years, maybe 10. But 7 to 10 years it's been outside. And this board with the conformal coating on it looks brand new. I don't see any issues with it. I don't see any degradation of parts, corrosion, or anything going on there. This is very, very well designed, and it appears that the quality of the design and the components and the workmanship are very, very good. The problem with the keypad was very simple. So the first thing I did was check the continuity between the plus terminal of the battery connector and the circuit board. And you can see that there's good continuity there. When I went to check the negative side, the black side, and I touched it to the outer ring, you can see that right now my continuity, I have open circuit. And depending on how hard I press down on this connector ring, right now I have good connection, and you see it's open circuit. If I touch the center to here, you can see that I have a pretty decent connection. It's moving around a little bit, but pretty decent connection. I noticed that when I first tested it, this negative connection was completely open circuit. So from this point here to here, it's completely open circuit. And I know what the problem is, and let me show you why. If you look at the plus battery connection right here, you see that the inside of this connector is very shiny, no corrosion, doesn't appear to have any issues. But the negative terminal, if you look carefully on the inside of this, there appears to be some corrosion in the center. So the way to think about this is these two connectors are actually two pieces. There's a back piece which is connected to the red and black wire, and then there's a top piece. And the back piece slips into the top piece, and then the back piece is swaged to create a mechanical connection and a mechanical bond. So over time, due to environmental influences, these mechanical bonds expand and contract with temperature, and due to the environment, there's some corrosion that sets up inside here. So what's happened in this case is the back part of this metal connector is making intermittent connection with the top part of this connector. And it's the top part of this connector that connects to the battery. It's the bottom part of the connector that connects to the wire and provides power to the control board. So I've decided I'm not going to resolder this. I think it's going to require too much heat. I don't want to melt this vinyl. I'm just going to restrike it and hope that that gives me the tighter connection that I'm looking for. So let me see if this twists anymore. No, this doesn't twist anymore. Obviously, when you're checking the connection with a meter, as you apply force onto this connector, you may in fact be improving the connection that was faulty. As long as you have a very low resistance between the outer and the inner, you should be good to go. Here you can see it's possible to do all the measurements and repairs without taking the control board out of the enclosure. So before I put the circuit board back into the enclosure, back into the box, I've connected my battery. This is my first test. Let's see whether the LEDs light up. Yes, they do. So I wasn't getting reliable illumination of the LEDs before that repair. It's lighting up nicely, just like it's supposed to. So thanks for watching. If you found this video helpful or entertaining, how about subscribing to my channel and give me a thumbs up.